Hello students, in previous lecture we have studied about the enthalpy of the system and relationship between enthalpy change and change in internal energy for the process which takes place in the system. Today we are going to discuss about the enthalpy change takes place during some physical transformation. Physical transformation, that is, there is change in the states of the substance, that is solid substance. When heated, it can be converted into liquid state. That means solid, on heating it converted into liquid, and liquid when heated it converted it into gaseous phase or vapor state, and vapors when cooled down or condensed, then that vapors are converted into liquid, and liquid when cooled, then it can convert it into solid. That means that is the physical transformation of substances, that solid get converted into liquid, liquid is converted into vapors, and vapors when cooled it converted into liquid, liquid on freezing it gives solid. And enthalpy which is related with those process we have to discuss on it. Then see here, first of all, enthalpy of fusion, and enthalpy of fusion which is denoted as, that is enthalpy change, that is enthalpy of fusion. Enthalpy of fusion, what is enthalpy of fusion? Enthalpy of fusion is nothing but it is a enthalpy change which occurs when that solid is converted into liquid state. But there are few conditions in order to determine the enthalpy of fusion of that solid substances. Then see here, first of all, I am going to discuss with you the example of that enthalpy of fusion. For example, see here, H2O which is in solid state, isn't it? Then H2O in solid state means it is a ice. When ice is heated, on heating it converted it into liquid state, that is ice is converted into water on heating. Ice molecules absorbs the heat energy to convert the ice molecules into liquid water, and the amount of energy, amount of heat which is absorbed by the solid water, that is ice, to convert it into water, that is the enthalpy of fusion. There is one more condition, that is here, when enthalpy of fusion of any substance when calculated or determined, then that substance should be taken is 1 mole. That means here 1 mole ice when it is converted into liquid water, but this process should be takes place at a constant temperature. That means here T should be constant as well as pressure should be constant, and here that 1 mole of solid substance converted it into liquid state, and here heat is absorbed by that solid substance, that is the enthalpy of fusion of that solid substance. Then enthalpy of fusion is nothing but it is a enthalpy change which occurs, see here, enthalpy change which occurs when 1 mole of solid substance, 1 mole of solid is converted into liquid. Here, without change in temperature and pressure. That is the enthalpy of fusion. In this example, 1 mole of ice is converted into liquid water, and here this process takes place at 0 degree Celsius, and here therefore heat absorbed by that 1 mole of ice is, that is written here in this chemical equation, that is here 6.01 kilojoule per mole. That is the enthalpy of fusion of solid water, that is ice, enthalpy of fusion of ice. Here enthalpy of fusion is positive, that is here heat is absorbed by the solid substance. Here we can write the definition of enthalpy of fusion, that is enthalpy of fusion is nothing but it is a enthalpy change which occurs when 1 mole of any substance which is in solid state, that means 1 mole of solid substance converted into liquid state at constant temperature and constant pressure. That enthalpy is called as enthalpy of fusion of that solid substance. That means here enthalpy of fusion of ice is 6.01 kilojoule per mole, and here enthalpy of fusion of any solid substance, it is always positive because it is a endothermic reaction, because here heat is absorbed by that solid substance to convert it into liquid state. Then see here, that is about the enthalpy of fusion. But here the process when reversed, see here the same process, but when it is reversed, then here liquid substance, that is H2O liquid, when it converted into solid water, that is ice, that means here water is converted into ice, and in this process heat is evolved by the system, and that heat which is evolved by that system, which takes place at same temperature, that is at 0 degree Celsius, is same as that of enthalpy of fusion. That enthalpy is known as enthalpy of freezing of that water, because here liquid water is converted into ice, then here enthalpy change which is related with that process is called as enthalpy of freezing, enthalpy of freezing, and that is minus 6.01 kilojoule per mole, because see, freezing of liquid water is the reverse process of that fusion of ice into water. Therefore here 6.01 kilojoule amount of heat energy is evolved when 1 mole of water is converted into solid ice at 0 degree Celsius at constant pressure without changing pressure. That means enthalpy of freezing is nothing but it is an enthalpy change occurs when 1 mole of liquid substance, see here, 1 mole of liquid substance is converted into solid state at constant temperature and constant pressure. That is the enthalpy of freezing of that liquid substance. Then we will discuss on enthalpy of vaporization. See here, vaporization, vapor formation. Vapor formation, that is liquid when heated it converted into gaseous state or vapors of that liquid. That process is a vaporization process. That means vapor formation process. And the enthalpy which is related with that process is enthalpy of vaporization. Then we will discuss about that by taking one of the example of it. That is, suppose at 100 degree Celsius at this constant temperature and at 1 baric pressure, that is here pressure is 1 baric and temperature which is 100 degree Celsius, at this temperature and at this pressure, here H2O liquid state, that is here water which is in liquid state, it converted into vapors of water. That means here liquid water is converted into vapors and here the heat absorbed by 1 mole of water to convert it into vapors of water, and the amount of heat energy which is related with this process is enthalpy of vaporization at 100 degree Celsius at 1 baric pressure, and enthalpy change which is related with that substance or with that process is about 40 kilojoule per mole, and that is the enthalpy of vaporization of water. Then we can write the definition for the enthalpy of vaporization. It is a enthalpy change which occurs when 1 mole of, see here, that liquid water should be 1 mole. 1 mole of liquid substance, liquid is converted into vapors without change in temperature and pressure. That means at constant temperature and constant pressure. That is known as enthalpy of vaporization, and enthalpy of vaporization of water is 40 kilojoule per mole. Here that enthalpy of vaporization is positive. That means it is an endothermic process at 100 degree Celsius. Here enthalpy of vaporization of water, it may be different if this process takes place at different temperature. If this process takes place at 0 degree Celsius, then enthalpy of vaporization of water, it may be different than the 40 kilojoule per mole. But that process should be takes place at constant temperature and constant pressure. Then see here, reverse of this process is a condensation process. That means here the gaseous substance or vapors of liquid when it is cooled, it converted into liquid substance. Then the enthalpy or energy, heat energy, which is related with that conversion is called as enthalpy of condensation. That means, see here, the reverse of this process is here H2O, which is in gaseous state. That means here water vapors when it is cooled, and here it converted into liquid water. That is, vapors are converted into water, liquid water, and the enthalpy which is related with this process, that is known as enthalpy of condensation. And here, as vapors are cooled to convert it into liquid water, then here heat is evolved during this process. And if this process is carried out at 100 degrees Celsius and 1 baric pressure, then here the same amount of heat energy, that is 40 kilojoule per mole amount of heat energy which is released during this process. That means here enthalpy of condensation of water, that is here water vapors, that is it is negative, because this process is a exothermic process, and that is of enthalpy of vaporization and enthalpy of condensation. We can calculate enthalpy of fusion of different solid substances at constant temperature and constant pressure, as well as enthalpy of vaporization, when enthalpy of condensation, and enthalpy of freezing of different substances, which is given in the chart in your textbook. Then see here we can discuss on, that is enthalpy of sublimation. Enthalpy of sublimation. Sublimation, all of you studied about that. Solid substance when get directly converted into vapors or gaseous state, that process is called as sublimation process. And here the sublimentary substances like camphor or iodine, here iodine, solid particles of iodine is directly converted into gaseous substance at room temperature, as well as camphor is also sublimentary substance, therefore it can be converted from solid state to gaseous state, as well as naphthalene ball, which is converted into gaseous substance at room temperature. Then here the process which is carried out, that is the sublimation of that solid substances or sublimation of the substance. Then here one of the example we will discuss on that, that is solid H2O, that means here ice. Then ice is converted into liquid water. Here 1 mole of ice is converted into water at constant temperature and constant pressure, and here that process is a fusion process, and here enthalpy which is related with this process is a enthalpy of fusion. All of you studied about that, and here enthalpy of fusion of that ice is 6.01 kilojoule per mole. Again here one more process, that is liquid water, that is 1 mole of liquid water when converted into vapors of water, and this process which is a vaporization process, and here the enthalpy which is related with this process is the enthalpy of vaporization. And if this process takes place at same temperature and same pressure, that is at constant temperature and constant pressure, then enthalpy of vaporization of liquid water is 40 kilojoule per mole. And here if we can add those two equations, then here we get the equation, that is H2O solid, that is ice, is converted into gaseous water. That means here liquid water get cancelled, and here we get the equation, that is solid ice is converted into gaseous vapors. And here addition of those thermochemical equation takes place here. Therefore we should add the enthalpy change which is related with this process, and that is here enthalpy of sublimation of, that is ice, and here that is of 46.01 kilojoule per mole, and that is that process which is takes place at 100 degree Celsius and 1 baric pressure, and that is the enthalpy of sublimation of solid ice, because here the enthalpy of sublimation, enthalpy which is obtained here, which is related with the process of conversion of solid into gaseous water, and therefore that is the enthalpy of sublimation of ice. And here the same process which takes place at different temperature, then here enthalpy of sublimation of water is also different. If this process is carried out at 0 degree Celsius, then here enthalpy of sublimation of water is about 51.08 kilojoule per mole. That means that much amount of heat energy is absorbed by the ice, 1 mole of ice, to convert it into gaseous vapors. That's enthalpy of sublimation can be represented or can be explained with the help of the triad. Then see here H2O here which is in solid state, here solid ice which is converted into liquid water, and the enthalpy which is related with that process is a enthalpy of fusion, and here liquid water is converted into water vapors, that is water vapors, and that process is a enthalpy of vaporization, and that means here enthalpy of fusion of ice, and here solid ice is directly converted into water vapors. That process is a sublimation of that solid substance, and enthalpy which is related with that process is a enthalpy of sublimation. From this we can conclude that enthalpy of sublimation is the sum of enthalpy of fusion of that substance and enthalpy of vaporization of that substance. That means that is the equation which we get for determination of enthalpy of any solid substance, and this process should be takes place at constant temperature and constant pressure. That is about the enthalpy of sublimation. that is about few physical transformations and enthalpy which is related with that physical transformations. Thank you.